we're over here. We've gone live, and I'm just playing with the kitty cats a little bit, and I wanted to give a little bit of an update as well. And I have not been very well. I've been under the weather is the reason why I haven't gone live in the last couple days, and so I just wanted to give a little update on that and show you the kitty cats, Fuji Suji Baji with the thanks to the universe. And yeah, that's about it. And I was gonna see whoever, if anybody joins, I can always say a quick hi, and then I will have to go rest, recover, and hopefully I will be able to do a normal live tomorrow. But yes, I was planning to be live every day, even really including the weekend days, but here I am. Wasn't quite able to do that this weekend, but here we are saying hi. Hello. Hello, hello, hello. I will hang out for a bit. I might, there we go. Here. You can see Baji. Hello, welcome to the live. How are you? Hello, hello. Thank you for being here. Welcome to the live. Just saying a quick hi before I go to bed. I know it's late, and I almost didn't go live today. I was gonna plan to do it tomorrow, but just saying a quick hello while I'm here, while I do this. And there is Baji, so enjoy the Baji view. How's everybody doing? Hello. Thank you for liking the live. Appreciate it. Thank you so much. Please do like the live. Thank you. Hello, thank you for liking the live. Thank you for joining. I'm going to go over this way. Hi, Jesse. 777, hello. There's Baji Baba. He's chilling. He's cute. Oh, thank you. He does. We're gonna go up and snuggle soon here. He is cute. Baji Baba, you're so cute. Hi Fuji, where's your red, Fuji has been playing with a red mouse toy. Ooh, I see it. I see it. Here, Fuji. Look at this. So Fuji has been playing with this red mouse toy. I'll throw it for him. And yeah. Thank you once again, everybody. We'll hang out for a few minutes, and I'm just touching base, hanging out for a little bit, and we will do our normal live tomorrow. Thank you so much for joining and supporting. Really appreciate it. He is sleepy. We've had a long day. For a few days, we've had a long day. That's for sure. Thank you. Just the cat stream. Fuji, Garnashana. Yes, Hi, Fuji. Fuji's dropping things. Well, we got the kitty cats covered in this channel. I have 2 dogs. I'm allergic to cats, but they're cute. Oh, thank you. Doggos are good too. Thank you for joining. Hi, Gru. GRU, hello. Hi, Tokyo, hello. Fuji, Mama will. You can bring it to Mama if you want. Yes, right. From. So I'm posting a clip called "Where Are You Really From?" I spoke about India and my travels, so that's what this is from. There's a live I have which covers that. So I've been posting some clips and stuff because I haven't been doing well. I still try to post some videos and clips and things like that. And like I said, tomorrow hopefully I'll do a what do you call you know a normal live stream. And hope to see you there. Sorry about the gap in the lives. Excuse me. Hi, Fuji Baba. I think Fuji's really happy right now because he's playing, and we had some we had guests, and he might have been a little shy, but now he's back to his usual form, which is really nice. Thank you, universe. And if you're seeing this live stream as a video upload later on under the live tab, thank you so much for joining. Thank you so much for watching the upload, and as always, please do leave a comment. Really love to see everything and all your thoughts and comments. Thank you so much for your continued support. Hi, Baji. Thank you. Why is on now? Okay. Had to message somebody back. Okay. Sundar, how are you? Thank you. Ooh, I never shared the live. There, shared it. Thank you. Thank you, Fuji. Oh, Sachi Mama is attacking the couch. Sachi! No, baby, garnish enough. Hi. Hi, cat. Hi, couch. Hello, alien. I like that. This cat, this couch. This painting is famous. crazy. Alien, how are you? I fooled you so many times. Oh my gosh. Oh, I can hear my voice twice. Whoops. Sorry. Sorry about the premieres. Are you talking about the premieres? Thank you for watching. Sorry, I've been sick. I was in the hospital. Sorry. Saying hi now. How are you doing? Versus live, yeah. Yeah, it's kind of like a live stream, but not quite. It's something like you can watch it together and people can still chat. It gives you it's a video with a chat option, so that people can still chat in the live chat for the duration of the video. But it's not quite like a live stream like here, where we are able to chat as long as, you know, the live stream is going on. At least now I know premieres are different. Oh, thank you. Chat option, but for the viewers. Yes, you got it. You got it. I'm better. I'm much better. My medication came in, like the pharmacy. So we had a snowstorm in Boston, you know, over the weekend. So like my medication got delayed, and like the pharmacy closed, and it was really difficult to get to the hospital and back and everything. But I got the help I needed and getting better. But I was gonna do a normal live, but like I don't know, I'm so tired. I'm just like just saying hi and doing a chill live for right now, and then hopefully I resume my normal lives tomorrow. Thank you for asking. Thank you. So what do you do? What do you mean about, what do you mean what I do? Like, you mean like a job? Is that what you're asking about? Oh, sorry. I just discovered. I just discovered your channel like a few days back, and honestly, you're the first one I found who talks about physics. Aw, thank you. Yes, so I cover astronomy, physics, cosmology, astrophysics. If you want, there is a ton of videos. Actually, my older lives, I've covered cosmology, astronomy, astrophysics. My background is in particle astrophysics, and I also show the cats. It's sort of like we hang out. Sometimes we hang out with my face on or with the kitty cats, and I'm just talking in the background or as a voiceover during the live, or it's my face on the live. But I basically cover, most of the time I cover physics, cosmology, and astronomy topics. And there's been a lot of astronomy topics recently, like planets, giant moons, Earth, our moon, how it was formed, black holes, the supermassive black hole at the galactic center, galaxies. We did a whole series of lives on just galaxies recently. If you go to my channel and go to the live tab, I talk about all these things. So, and sometimes the naming of the live isn't super specific because I don't know yet what I'll talk about. Because sometimes the live discussion on the physics topic is based on somebody's question. Like, I think somebody asked about quasars at the last live, so I talked about quasars. Um, I think on the live, that was my last sort of longer live before this one. Um, so yeah, we covered galaxy classification, the spirals, ellipticals, irregular galaxies. We also talked about active galaxies. I've also covered evolution of the universe in the early universe, Big Bang and Big Bang nucleosynthesis and cosmic inventory. So those are sort of a sampling of different topics we've covered. We also talked a lot about Einstein and his work, and the lives go back several months. So feel free to catch any or all of them. Thank you so much. I cover astronomy, physics, cosmology, astrophysics topics. Working with NASA, did you see that Einstein ring image? I guess Euclid. Yeah. Um, it's been a while though. Let me Google it. Oh, nice. Yes. It was a while ago. Gravitational lensing occurs when the gravitational. So yeah, we talked about gravitational lensing. I kind of forgot about the verbiage, Einstein's ring, but we talked about gravitational lensing as a way to find compact halo objects that may have been a candidate for dark matter. So by the way, this reminds me, we also talked about dark matter candidates, dark energy, those types of topics that are currently under research, but we don't know the answers exactly. So all those types of topics are also fair game on the channel. So hopefully you'll come to the lives. This is a sort of a weird live because we're not covering a physics topic today because I've been sick. I'm just kind of saying hi. But most of the live streams we cover some interesting topic like that. So hopefully you'll come to a lot of the live streams. You can subscribe and get notified, and you can ask your questions too about any topic you want from hopefully just I would say physics, astronomy, astrophysics, cosmology would be great. Gravitational lensing. Bullseye patterns are so-called Einstein rings. Oh, thank you. Did you see that Einstein ring image? I guess Euclid. I cover astronomy, physics, cosmology. That's what I said. I subscribe with 3 accounts. Thank you. Oh my gosh, thank you. That's lovely. See you at the lives. You can also request a physics topic if you have a special interest. So my specialty is mainly particle astrophysics, but I also talk about and learn about actively, and discuss cosmology quite a bit. I love cosmology, universe type of things, universe related questions. Astronomy, I'm an active student of astronomy, so anything astronomy too, would love to talk about. But my exact background, my PhD is in particle astrophysics, so. But any questions in physics are all fair game. Feel free to ask, and I can try to cover your special interest as well. I've not been to CERN. My background is in particle astrophysics, so I did not go. I didn't really do the collider stuff. So I was interested in particle acceleration in natural particle accelerators like gamma ray bursts. So it's sort of an intersection of particle physics with astrophysics. That's kind of where I worked. So I did not do the collider, like Large Hadron Collider type of experiments or CERN. I have not been to CERN, although I hear the bread is good there. What do I call you? Particle physics. Nice, you've been to CERN. Well, my username is OindriB, and the name of the account is Baji the Handsome Cat. Some people call me Baji's mom, or just the username is fine too. Or Baji mom. I like your username, Alien. Love it. Oh, that reminds me, Alien. We talked about potential aliens as well, from the approach of finding habitable planets. Well, we tried to search for planets, so I talked also about exoplanets in a few different live streams, at least in one live stream, very focused on exoplanets. So I hope you go to the live tab and kind of just listen to, you can just let them, listen to the older lives and let them play. Hopefully you'll find interesting discussions. Some of the lives are very actively discussed, as in there's a lot going on in the live streams. So apologize if there's, sort of a distraction, and, a lot of things happen, lots of people engage in these streams. But I try to cover as much as I can with the science topics. So appreciate your support and thank you. Inflation. Oh yeah, for sure. So struggle a lot to understand inflation. Okay, I can definitely gather my notes on inflation for next time. That's a great point. I'll make a note of it. So are you talking about sort of like expansion of the universe, like that sort of thing? Dark energy, cosmology question? Love it. I love cosmology, so we will definitely cover this. So basically we talked about the expansion of the universe. So, basically the cosmological constant is where it kind of started. If you've heard of this concept called the cosmological constant, sometimes it's given a symbol of lambda, big lambda, Greek letter. And basically, over 100 years ago, when Einstein was writing down the equations for general relativity, which is basically the updated theory for gravitation in this, universe. Granted, we didn't really know how big the universe was and how many galaxies there really were at that time. We soon found out thanks to Hubble. But over 100 years ago, our view of the universe was quite limited, as in we hadn't really yet made the observations of exactly how many galaxies there were out there, for example. And we did not really know about the expansion of the universe. So then, at that point, though, itself, so even before these types of observations were being made, I just want to stress that, right? Because now we have observational evidence for the fact that the universe is expanding. Not only that, its expansion is accelerating, but I just wanted to give you the history that the cosmological constant is over 100 years old, and you will see why this cosmological constant is important, because it basically leads to the concept of dark energy. Dark energy is basically a more general form of the cosmological constant. So this term, cosmological constant, quite literally, this extra term was additional term, was introduced by Einstein in his equations to balance out gravity in the universe. Basically, everybody was like, well, not everybody, but people raised the question that, well, gravitation is an attractive force, so it should make things kind of collapse, but the universe does not collapse on itself. So what's kind of holding things, what's kind of acting against gravity? And in fact, he was not the first person to deal with such a problem. Even Newton was asked about this, where gravitation is inherently an attractive force. Now, granted, In general relativity, gravitation is the curvature of space-time. It is not a force, but still, he needed some kind of term to balance things out and not basically go against the collapse of material upon itself in the universe. And he called it cosmological constant. So as at cosmological scales, why aren't things collapsing? Why are they balanced against gravity? Now, little did we know at that time that this cosmological constant is actually going to be very important in the form of what is now considered what we call dark energy. Because we saw Einstein introduced this concept or this constant, quite literally a term in the math, because he had to. He had to put something in order to go against gravity or balance out gravity. He did call it his blunder at one point, yes, but basically, not only was it not a blunder, it was actually like magically, miraculously quite important, because it's the same cosmological constant concept that we still deal with. And we found that the universe, so Hubble did observations, we spoke a lot about galaxies recently in the lives, and those types of concepts, the names of these galaxies, the classifications of these galaxies, those all come from originally from Hubble's observational work. And this type of observational work actually showed that the universe was not just balanced against gravity at cosmological scales, at cosmic scales. Not only were things not collapsing upon itself under the force of gravity, but things were actually expanding out. The universe was expanding. And then even more later, towards the current century, we found that the universe's expansion was not only happening, so it's kind of like not only are things balanced against gravity, something, some force, some energy of the vacuum is actually pushing things out. Like it's not only balanced, but the universe is expanding. And the universe is not only expanding, its expansion is accelerating. So now, with our latest and greatest cosmological understandings, we actually have a list of cosmic ingredients and their proportions and contributions to what we call the energy density of the universe. And it turns out that this thing, this cosmological constant, more generalized, which is called dark energy, is what is the dominant contributor to the energy density of the universe. So dark energy is up there, followed by dark matter, and then ordinary matter. So this expansion of the universe, sometimes called cosmological constant, is the topic of dark energy. We don't quite understand what it exactly is, so we call it dark energy or invisible energy. And of course, it's important at the cosmic scales. And we talked about how we have evidence of it as well in, I think, multiple of my cosmology lives. So that's what the expansion of the universe is. It has to do with dark energy. We've also talked about dark matter, which is a different topic. It's not the same thing. It's this extra matter or invisible matter that we also have evidence for. But the expansion of the universe, which is a cosmological phenomena, and it definitely affects things at the cosmic scales, at the larger scales. That topic is strictly sort of a cosmology topic, whereas I've mentioned how dark matter can be studied under astronomy, astrophysics, or cosmology. So yeah. Just FYI, I don't have a science background. I never went to college, so clearly. Yeah, that's okay. We cover the topics both sort of, I mean, I do cover the math sometimes, and people kind of tough it out, they sit through it, even if they don't kind of get it, or they're still like interested in hearing about it. Uh, but also we talk about the concepts more generally. So don't be afraid. We might mention some of the math, but that's not all. Like we mention everything generally, and sort of I try to do my best communicating the concepts without getting hung up too much. But I do get hung up sometimes on the math, I will say, but not always. So so yeah, hopefully that was helpful. But a lot more detail is in my cosmology lives, where I talked about this. You'll see in the under the live tab if you try to find the um, you know what, I should probably do a dedicated live and call it dark energy or expansion or something, so that people can more easily find that. But this topic is definitely, I've covered it under some of the other lives, and you'll probably benefit from listening to those. But yeah, that's the sort of in a nutshell spiel on dark energy. It's an active area of research. So sometimes I say that the biggest open questions of the universe are number one, dark energy, because that is the most that is where most of the energy density is, or the energy content is. So dark energy is a big open question. We don't quite understand it. There are active collaborative efforts trying to understand it further, like the dark energy survey experiment, as well as dark energy spectroscopic instrument. If you are really interested, you could look for those types of efforts online and see their papers, and you can dig into it as much as you like. If you're interested in the expansion of the universe, then you'll see it's pretty much going to be in the same vein as all the dark energy work. That's what people are doing when they say dark energy. That's what they mean. And yeah, just don't get it confused, I guess, with dark matter, because that's another whole topic. So it's like there's there's I would say there are three main open questions of the universe right now. Number one, what is dark energy? Number two, what is dark matter? And number three, origin of some of the elements that we don't yet understand. So, of course, the elements are important because we are made of them. They're not the most dominant thing in the universe, but because of their great importance and relevance in our lives, we do want to understand how all of the elements in the periodic table are made, and some of them are less understood than some others. And so some of that research is also a top question. I wanted to give you the top three research questions, but yeah, the first, definitely, I would say a big one is the dark energy question that you asked. So very good question, very relevant, very much a topic of research. I'll put in the chat the names of those experiments. I'm so happy that you exist. Oh, thank you. Thank you, Alien. Hello, John. John, have you been coming to my lives? Because I have seen some of your comments, and I'm not sure if I've seen you in my live before. So, well, welcome. Thank you for watching, John Jones. So that's one survey. The dark energy survey is older. So feel free to, look these things up and read about them much as you please. I'm so happy that you exist. Oh, thank you. Me too. Thank you. So, dark energy survey, look it up, see what you can find, papers, everything like that. And then the next thing I will put in the chat is also dark energy spectroscopic instrument. This is a newer effort, but honestly, at this point, it's not that new either. Hopefully, they've pushed out certain papers and things like that. So you can keep up with the literature for this topic if you would if you would be interested. These are very huge collaborative efforts, and it's part of the job actually to make sure the public knows about these efforts. I don't directly work on these efforts, but whatever I can find and share, I will. I think definitely the question you ask is very relevant and one of the biggest topics of today. So we will definitely keep informing everybody about it. I bought the book Six Not So Easy Pieces by Feynman, and boy, it flew over my head. I see. Oh, Six Easy Pieces was easy. Aw, well, that's so cool. I'm glad that you're reading and, figuring it out. Sounds like. So, dark energy spectroscopic instrument is the newer cousin effort. um, Sometimes I pick up the wrong thing, which is way beyond my intelligence. Well, I would say, it's not really intelligence. It's about sort of sometimes, the formal education helps with setting things up, and maybe that's sort of missing in the book. So maybe the book is not very self-contained, is why it could be hard to follow. So I would not think that that's a lack of intelligence. It certain things in physics really builds on other foundations. Unfortunately, like physics grad school is fun after like a few years. And so physics undergrad might not be so fun, right? So it's kind of like one of those fields that requires so much foundation that it's kind of hard. So I think it's not really an intelligence thing. It's more about what concepts are covered as the introduction in the book. But yeah. Aw, well, we can certainly help with some foundation. We cover a lot of different topics. Actually, something else we covered in astronomy we covered some pretty basic astronomy facts and like the Earth and sort of a history of science kind of way as well. So it's sort of a variety. It's mostly gonna be just physics, astronomy, cosmology, astrophysics, but sometimes we cover things that are pretty basic as well. So hopefully we can help with some of the foundations. I would say another way to think about it is the physics is really the foundations are really just classical mechanics, quantum mechanics, and E&M. So if you want to get the foundation, we talk about these topics sometimes as well. I can try to make it more organized, but really, like if you're looking things up on your own, I would say the physics sort of foundations are classical mechanics, that's like Newtonian mechanics. Most large, most things that are in the scale of you and me, trees, cats, cars, planets, moons, will follow classical mechanics or Newtonian mechanics. NASA is still using that, to send rockets and stuff. So that's like Newtonian mechanics. Pretty much physics is about sort of a major sort of foundational type of thing that physics really is sort of understanding like a position of something with respect to time, like position of an object as a function of time. So another way of putting that would be the position of an object as time changes, right? And basically in classical mechanics we are able to say that pretty deterministically. We're able to write that down. We have some laws, we have some things we understand thanks to people like Kepler, Galileo, Newton. These people gave us so much work in that topic that we can literally, if you told me the position of the moon as a function of time, we could like predict it out for years, you know? So something like that would be classical mechanics. I'm just giving you the foundations of physics in a nutshell here. The next thing is quantum mechanics. This is basically mechanics or the physics of the very small. So instead of being interested in the position of the moon as a function of time, you might be interested in the position of an electron in the hydrogen atom as a function of time. You might say, hey, I'm not really interested in cars and trees and cats and houses and moons and planets, but especially planets in our own solar system. Because, fun fact, if you go to cosmic scales, of course, you would need general relativity instead of Newtonian mechanics, but that's a detail at this stage. Quantum mechanics is where you're interested in small things like atoms, electrons, positrons, protons, neutrons, things like that. So if you're interested in understanding position of an electron in the hydrogen atom as a function of time, you might have to write it down as the particle wave equation that Schrodinger did. And turns out that unlike classical mechanics, it's not to be found deterministically, but it's more of a probabilistic answer that you get. You get the answer that the position of time, the position of an electron as a function of time, when it comes to something like a quantum of stuff, such as an electron, is given probabilistically. You don't know for sure, okay? And that is the nature of quantum mechanics. And some people really don't like that. They don't like the fact that quantum mechanics is probabilistic and kind of weird and deals in uncertainties, and uncertainties are part of the mechanism of quantum mechanics. It's not a mistake, but a fact of nature, right? So that's quantum mechanics for you in a nutshell. Obviously, I'm saying things in a very short way. Lastly, the pillar of foundational physics would be electromagnetism, E&M. So E and M, electric and magnetic fields. Turns out that electric and magnetic fields are kind of the same thing, and they can interchange to each other. And a bunch of people like Maxwell and Faraday did a lot of really good work to give us how electric and magnetic fields change and behave, and how those things can be written as a function of time, and how charges, what the electric field of some charge is, and at what distance, etc., etc. Those things are postulated by Maxwell's equations, and a constant in these equations turns out to be the speed of light in vacuum. And then taking this a step forward, and many steps really in the form of insight, is the special theory of relativity, where Einstein shows that the speed of light in vacuum is a constant of nature, and that gives us the relative nature of space-time and energy mass equivalence. And so it's kind of like taking E&M and getting this very deep insight from it. But of course, a foundation in E&M is what's needed to understand, not to understand, but to appreciate special theory of relativity, and to get the more updated theory for light. Because basically when they did electromagnetism and they showed that basically this is the wave nature of light, electric and magnetic fields changing and oscillating is light. That's light, right? It's an electromagnetic wave. So that gives us the wave theory of light. That's the speed of so the speed of light is a constant. So depending on the wavelength, you're asking about the wavelength of light. Basically, you can have a different wavelength light. If the wavelength is different, then the frequency will be different. So sometimes we think of it as a color. Basically, you can have radio waves or X-rays or visible light or microwaves. Those are all electromagnetic waves. They're all forms of light. Um, Depending on if you change the wavelength, then you would change the frequency. But the thing that stays constant is the speed of light in vacuum. So the speed of light in vacuum is a fundamental constant of nature, which, when absorbed into our brains really deeply, we see that that has some very interesting insights, such as what we get with special theory of relativity. So those are the foundations: classical mechanics, quantum mechanics, E&M, and then special theory of relativity is an updated E&M theory, basically. And then general theory of relativity is an updated theory for gravitation if you need that correction to Newtonian mechanics, which you would not get if you didn't do general theory of relativity. And then, of course, there's particle physics, but they all travel at the same speed, right? Yes. Correct. Yep. They all travel at the same speed. In the same, they would all travel at the same speed in vacuum. Yep. What do you think came first, light or sound? So it's definitely light, because if you're talking about the Big Bang, I mean, the universe in the beginning was radiation dominated. So we actually talked about the evolution of the universe, and close to the Big Bang, after the Big Bang happened, our universe was extremely radiation dominated. So I would say light came first. And by radiation dominated, I mean that it was basically a cosmic, hot, dense, energetic cosmic plasma made of photons, electrons, and positrons. The Big Bang naming is not quite the most accurate. There's nothing really happened that was big or a bang, so the name just kind of stuck. The Big Bang is the name of the, just the beginning of the universe, but it's not really very appropriately named. But we have stuck with that name because of just, it stuck. But yeah, so those are sort of the foundations. I didn't talk about particle physics as a foundation, because really the foundation for particle physics is quantum mechanics. If quantum mechanics had not continued to be super successful experimentally and everything, then then particle physics would not develop to the point that it has. So I will leave the foundation to be the things I mentioned, but particle physics is also an important pillar. I will say, because you asked about, or you mentioned about the foundation, I thought about this way of presenting it, so thank you for that, and I will try to organize it more like this. Considering there is a limit to our vision of the universe, we might be inside a black hole. So part of it is that light takes finite time to get here. So some of it is because of the finite speed of light. We wouldn't be able to see certain things. And the other is an observational limit. We can't see farther than, something. So, or we can't resolve very well beyond a certain point, probably. So I would say, I don't know if we're inside a black hole. Maybe. we know that we're in a galaxy and there are a lot of other galaxies. So all of these things that we know of, including all of the galaxies, would have to be in the black hole, because once you're inside a black hole, you can't see outside of it. You can't really come out of it. So everything we are able to see would have to be in that same black hole if we're in a black hole. So I'm not sure. I don't know that we are. I don't think that we are in a black hole. If you, but I don't really know. I know that I know we are in a universe that has gone through a lot of changes from the beginning. But yeah, thank you for chatting. Thank you for subscribing. Really appreciate it. Any other questions today, my friends? Thank you for being here. Hi, Sachi. Baby. Suji Mama is playing. Aww. Let me see the live on my phone. Oh yes, absolutely. It's a good sci-fi concept. Yes, indeed. For sure. It's a good sci-fi concept. Isn't it late for you? I have tons of questions, but I'll save them for later. Take care of yourself, fellow alien. I will see you soon. Bye. See you soon. Oh, can we get 10 likes, please? Good night. Thanks for chatting. Yay, could we get 10 likes? Thank you, thank you, thank you. Yes, hopefully I'll feel much better tomorrow and I'll do a normal live with my normal physics and astronomy spiels and you can come and enjoy. You'll have to bring more questions and we can go through it. And yes, I will take care until then. Definitely need to. Yay, thank you. Yay. Look at Sachi. Oh, thank you. Thank you so much. You have 10 likes now. Yes. Thank you. Appreciate it. Just like to hit my goal. I didn't even realize that was my goal, but yes. 11. Good night. Good night, cats. Good night.